Have you ever wondered how AI decides what to say next? Like, what is happening inside that digital brain the moment you type something? If you've ever imagined tiny robots flipping through dictionaries inside a server, you're very, very far from the truth. The real story is even cooler. In this lesson, I'll show you exactly how modern AI models think using simple visuals and zero math trauma. Welcome to Module 3 of Gen AI. From zero to hero. And today we're finally opening the hood of the engine. Here's the secret. People who understand how AI works, even at a high level, write better prompts, get more accurate results, and troubleshoot mistakes effortlessly. This is the module where you go from "I hope AI gives me a good answer" to "I understand why it answered that way, and I know how to improve it." That's a huge skill advantage. When you type a sentence, AI doesn't read it the way humans do. It breaks everything into tiny units called tokens and then converts those tokens into vectors, basically lists of numbers. Think of it like translating English into a kind of mathematical language the model understands. Every response AI gives you begins with this step. So what are vectors? Vectors represent meaning in a mathematical space. Words that mean similar things land close together. Opposites land far apart. It's like GPS coordinates, but instead of locations on Earth, they represent concepts, relationships, and vibes in language. Embeddings are the AI's map of the world. They capture how words relate to each other. Cat is near animal, ices is near cold, love is near affection. AI doesn't understand like a human, but embeddings give it a structured map of meaning it can reason with. In simple words, a neural network is just a stack of layers that slowly transform information. Each layer adjusts tiny parameters while processing your input, and by the time your request passes through all the layers, the output becomes meaningful. No neurons, no biology, just math blocks working in sequence. Transformers is the breakthrough design behind all modern large language models. Transformers let AI process all words in a sentence at the same time, making it incredibly fast and surprisingly coherent. Before Transformers, models struggled with long sentences. Now they can track relationships across entire paragraphs. Attention tells the model which words matter the most in a sentence. It figures out relationships like, "The phone rang, I picked it up." AI uses attention to understand that it refers to the phone, not your cat, not your coffee mug, the actual logical connection. This single mechanism changed everything in the AI world. One attention mechanism isn't enough. Language is too complex. So transformers use multiple heads examining different relationships. One looks at sentence structure, one looks at references, one looks at tone, one looks at meaning, one looks at emotion. All of these perspectives merge to produce a strong, well-rounded understanding. AI predicts the next possible word from a list of likely options. Some choices are safe, some are creative, some are chaos. Temperature controls this. Low temperature. Precise, controlled, factual. High temperature. Imaginative, risky, sometimes unhinged. So, yes, that's why the same question sometimes gives different answers. It's not mood swings, it's randomness by design. Large language models don't have infinite memory. They have something called a context window, the maximum number of tokens they can remember at once. If your conversation gets too long, the oldest information gets pushed out. So when AI forgets something, it's not ignoring you, its memory buffer simply overflowed. This is the one everyone talks about. AI doesn't know things, it predicts what should come next. When the pattern isn't clear, it guesses. Sometimes that guess is excellent. Sometimes it's confidently wrong. And because the model sounds fluent, the mistake feels believable. This is why checking important answers is non-negotiable. AI is trained on human-created data, and human-created data contains bias. The model isn't intentionally biased. It simply mirrors patterns found in the training set. Understanding this helps you evaluate AI output more responsibly. LLMs don't calculate like calculators. They don't verify like databases. They predict based on patterns. So sometimes the model writes a beautifully worded explanation with a completely incorrect answer. This is a feature limitation, not a glitch. And knowing this empowers you to use AI smarter. Here's the full journey of your prompt. Your text converts into tokens. Tokens convert into vectors. Transformers process them. AI predicts the next token. The model decodes everything back into readable text. This happens for every single word in every single response. It's shockingly fast and incredibly complex behind the scenes. A transformer block has several components: normalization, multi-head attention, residual connections, feed-forward layers, and your prompt moves through dozens or even hundreds of these blocks. Stacking them is what makes large models powerful. Bigger models have more parameters, more training data, larger context windows. More parameters mean more detailed patterns. More patterns mean better reasoning. Better reasoning means more reliable output. But bigger also means more expensive to run, so not every task needs a giant model. Watch how this works. The phone rang. I picked it up. AI uses attention to link it phone. This happens thousands of times inside a single response. This is why the model feels smart, because it understands relationships between words. Fun time. Let's practice. Try this hands-on exercise right after you have watched this video. Pick a sentence. Ask the AI, show me the tokenization. Then ask, explain the attention pattern like I'm a complete beginner. You'll literally see how the model processes text. And I promise your understanding will jump instantly. And that wraps up Module 3. You now understand tokens, vectors, embeddings, attention, hallucinations, and the entire flow of how LLMs think. Coming up next, Module 4, Smart Prompting and Simple Workflows. This is where you start using AI like a professional, not a casual user. Before you go, hit like, subscribe, and save this video so you can review the slides and diagrams again. If you want to learn more on AI, Gen AI, get updated news, visit our site www.thegeniuscircuit.com. So goodbye, take care, and I'll see you in Module 4, where your prompting superpower begins.